Let's start with the first question. So consider a data set that has only 100 points, out of which 20 points have the value 1, 50 have the value 2, and 30 have the value 3, right? And we are given parameters p, q, and r, right? Which are the probability of x being 1, 2, and 3 respectively. And they are asking us to find the likelihood function for this data under the distribution. So what does the likelihood function essentially mean? So the likelihood function of is a function of the parameters, right? So in this case, it's a function of p, q, and r. But we will write just as a function of p and q. Why is that the case? The reason being, since it can take only three values, right? It means p plus q plus r would be equal to 1, right? Now, since p plus q plus r equal to 1, only two of them are independent, right? The other one is automatically chosen. So we can essentially write r to be 1 minus p plus q, right? So since you can represent r as a function of p and q, we will have that the likelihood function is only a function of p and q, right? At the same time, you can also take it as a function of q and r, but only two of them at a time, okay? Now, the likelihood function is such that we determine the probability of observing that particular sample, right? So the probability of observing that sample uh, given p and q, right? And what is that equal to? So what is the sample all about? It's about 20 points having the value 1, 50 having the value 2, and 30 having the value 3, right? So 20 points having the value 1 means that p to the power 20. Why is that the case? Because since we are assuming a random sample, right? We assume that all of them are independent and identically distributed. So we can take the product of the probabilities, right? And at the same time, we can do q to the power 50 and then r to the power 30. But instead of r, we can write 1 minus p plus q to the power 30, right? Or we can write it as p power 20, q power 50, r power 30, right? Where r is equal to 1 minus p plus q, right? So this is the likelihood function. The next question is, what is the value of p plus q plus r? So this is already done. We know that the p plus q plus r should be equal to 1, right? Now we are supposed to find the maximum likelihood estimate of p, right? How do we go about that? So in order to find the maximum likelihood estimate, what we do is that we try to first reduce the likelihood function to a log likelihood function, right? So the log likelihood function, log of L, would be nothing but 20 log P plus 50 log Q, and then we have plus 30 log of 1 minus P plus Q, right? Or 1 minus P minus Q, right? Let me denote this by LL, right? Log likelihood. Now, if I take, so we need to find the, first we will find the maximum likelihood estimator, right? What do we have to do? We have to take the derivative of the log likelihood with respect to P. That would be equal to 20 upon P plus 30 upon 1 minus P minus Q, and then this will be negative instead of a positive sign, so this. And now we have to set this equal to 0. So when I set this equal to 0, that 20 times 1 minus p minus q is equal to 30 times p, which is same as saying that 20 minus 20p minus 20q is equal to 30p. That is same as saying 50p is equal to 20 minus 20q. Okay, so this is one equation that we got, right? Now we also have to take the double derivative with respect to q, which would be 50 by q minus 30 by 1 minus p minus q. And again we set this equal to 0, which happens if and only if 50 minus 50p minus 50q is equal to 30q, right? then we can say 50p plus 80q is equal to 50, right? And this equation here, this can be rewritten as 50p uh, plus 20q equals 20. Now, now we can say, okay, so using these two equations, right? What we can say is that 60q will be equal to 30, which means q is equal to 1 by 2, and p is equal to uh, so I'll say p is equal to 50 minus 80q, which is 40 divided by 50, right? So that is equal to 10 by 50, which is 1 by 5. So we've got p is equal to 1 by 5 and q is equal to 1 by 2, right? Okay. What do we do now? So this doesn't end here. We also have to check if, so what will r be? R will be equal to 1 minus p plus q, right? Which is 2 plus 5, which is 7. That is equal to 3 by 10. Right? So r will be 3 by 10. Okay. Now we need to find the double derivative of the log likelihood and see if this actually satisfies the maximum criteria, which means we want the Hessian matrix to be negative definite, right? Okay. So what we have to do, first of all, let's consider this term where we take the double derivative with respect to p. What will that be? That will be minus 20 upon p square, right? And then you have minus 30 upon 1 minus p minus q whole square, right? Right. Now, if I put the value of p equal to 1 by 5 and q equal to half, what would I get? So this would be minus 20 upon p square. So that would be multiplied by 25 minus 30. So 1 minus p minus q would be nothing but r. So r square would be 0.09. So 30 into 0.09, sorry, 30 into r square would be 100 by 9. Okay. So this would be equal to negative of okay, so in any case, we are sure that this will be negative. Okay, that is the first observation. Okay? So some negative of some number, so again this is negative. Right? Okay. Now we will observe that if I take the partial of the log likelihood with respect to q double derivative, right? I'll get a similar equation, right? So it will be minus 50 upon q square minus 30 upon 1 minus p minus q whole square. Okay? Again, it is a negative number, right? Now we have to look at two more terms. What are they? Consider the log likelihood, right? You first take derivative with respect to p and then with respect to q, right? So essentially what you have to do, you have to take derivative of this guy with respect to q, right? Which will be minus 30 by 1 minus p minus q whole square. Again, this is negative, right? Okay. By the same logic, we can see that if I take the double derivative first with respect to q and then with respect to p, it will give me the same value. Okay, minus 30 by 1 minus p minus q whole square. Again, this value is negative. Right? Now, what can you say about the Hessian matrix? Right? The Hessian would be, first here there's a negative number, there's a negative here, there's a negative here, and there's a negative here. Right? So we have to show that this is negative definite. Right? What do we need? We need to show that the first term is negative, right? Which is obviously the case. Then we need to show, then we need to do some computation. Okay, we need to show that the determinant of h should be positive. Okay, so we need to do some computation. So I've calculated the Hessian by putting the values of p equal to 1 by 5 and q equal to 1 by 2, and I have obtained this matrix. Now you can observe that the first entry, which is h11, is negative, right? And the determinant of h is equal to uh, 833 point something multiplied by 533 point something minus of 333 point something multiplied by 333 point something. Right? So essentially both these numbers are bigger than these two numbers, and so this will be positive. Right? So we have that. So this actually meets the criteria that h is non-negative, or h is negative definite. H is negative definite. And what does that mean? That means that the values p equal to 1 by 5 and q equal to 1 by 2 maximize the log likelihood, right? Which means these are the estimates, right? So essentially you can say, okay, uh, the estimates for p is 1 by 5, which is equal to 0.2.